Hi guys, in today's video we're going to be looking at a very simple experiment you can do with your class, with the whole purpose of it being to actually design their own experiment that involves a fair test. So this isn't necessarily designed to meet any particular experience and outcome, but I think more importantly to develop those scientific thinking skills for how to design a test and how to make it a fair one. And that's something that kids don't get enough practice of. The thing that gave me this idea, and I want to tell you this so that you maybe start thinking about things that you read in this sort of scientific way. I picked up one of these 1,000 facts that you didn't learn at primary school books. You just had it lying about in my class library. And while I was leafing through it, I noticed one fact that just stood out to me a little bit, and it was, did you know fire burns faster moving uphill than it does moving downhill? I thought, hey, there's an experiment in that. We can test it right away. Does it meet any particular outcome? Not necessarily, no, but that doesn't matter. There's an assertion, and we can design a fair test to test that assertion. Now, inevitably, in order to test this, we are going to be burning stuff. So let's get the safety precautions out of the way. First of all, you will need to provide your kids with ceramic burning mats. I recommend using splints as your fuel source for burning. They're very easy to get hold of, mass-produced, and they burn very cleanly, so they're less likely to trigger asthmatics in your class. Have a fire blanket on standby just in case, and a fire extinguisher just in case. And a beaker of water for your kids just to extinguish the flames. So the assertion then, so you make the assertion to your kids, fire burns faster uphill than it does downhill. From there, it's kind of up to them to design the experiment. Now you might want to offer some prompting questions, be a little bit Socratic, see if you can pull the answers out of them. But ultimately, the experiment needs to come from them. It needs to be a fair test from them. But you might want to scaffold it a wee bit, especially when safety is concerned. So they're going to be burning a splint, and they'll figure out fairly readily that they'll want to be burning it on different gradients. So they'll do one on maybe a 0 degree plane, a 45, a 90, and since it burns faster uphill compared to downhill, we probably want to compare downhill gradients as well. So negative 45 and a negative 90, and compare which ones are faster. However, you need to make sure that it's done safely and also fairly. It needs to be over the same distance. So they'll be measuring a set distance. Now that distance could be the whole length of the splint, but the problem there is that's eventually going to be reaching your fingers. So that's not going to be particularly practical. So you could get your kids to think about, well, how do we establish the same distance for all of the flames, but make that a safe distance? Now you could just set it as the halfway mark. Easiest way to do it probably is just to lay all your splints out side by side, and then just mark on with a pen where that finishing point is going to be. So that's that there. Now they all have an equal finishing point marked on the splint. And then you can just do the test. So you can have different people holding them at different gradients. So this would be a 0 degree, 45, 90. But I'd also encourage them to be checking each other to make sure that they're each being fair. Now you might want to time it as well. They might give them options. Say, well, do you want a stopwatch? Is that going to be helpful? Why might that be a useful tool in this situation? Get them to actually think about that. So they can time the distance and then they can actually compare it. Remembering, of course, that comparison is the essence of experiment, and that's exactly what we're doing here. We're comparing different conditions. So they can do it on a 0 degree plane. Obviously, I've now made it not a fair test because I've just changed the variable within the same test. But you can see why it would be the case that a 0 degree works faster than a 45, which is faster than a 0, and which is faster than downhill gradients. So it's a cool one for them to test. In terms of the safety of it, that's what the beaker of water is for. So if they at any point feel uncomfortable, or just at the end of the test generally, they can just douse that in the water. So I think there's a lot of validity to that, just in the sense that they get to design their own test. I'd really encourage everyone to give it a try, and I think it's a valuable undertaking. So please give it a shot. Cheers.